Hi students, today we are going to look at this interesting topic in chemistry. This is the continuation of the last video where we discussed about the petroleum and petroleum fractions, how they are produced through the separation techniques known as fractional distillation, where I told you that the fractions of petroleum are separated based on their different boiling points. Okay, now here in this video we are going to look at cracking, reforming, and octane number. All right, octane number here is known as petrol rating. Okay, which is used to rate the grade of petrol. Petrol rating is used to rate the grade of a petrol. Now let's start with cracking. Okay, cracking. Cracking on the board is the process of breaking down longer chain hydrocarbons into a mixture of smaller chain hydrocarbons. All right. For example, the longer chain hydrocarbon like kerosene, diesel, or lubricating oil. Here, let's use kerosene that has carbon atom 11 to 15. This is the structure of kerosene, the molecular formula of kerosene. Then kerosene can be split into octane. This is octane. Then here is propene. Okay, this can be split into nonane and ethene. Here is ethene. Here is propene with the double bond. All right. Here are the alkane produced. Here is nonane. All these are examples of alkane. Then here are the alkene. Okay. Now, the essence of this cracking is to increase the quantity of the hydrocarbon. Okay. Then it could be to obtain alkene, which is used in plastic industry. Okay, cracking is one of the methods used in the preparation of alkene, which is used in the plastic industry. All right, so I said that the essence of the cracking is to obtain higher number of hydrocarbons, which I said is to increase the quantity, or maybe it could be to obtain alkene, which is used in the plastic industry, because we were told in past question that alkene here is used as a raw materials in plastic industry. All right, now this is that about cracking, breaking down of the longer chain hydrocarbon into smaller chain hydrocarbon that are discovered in form of a mixture. And this mixture here will be separated into different components by the process known as fractional distillation. Just as we did in petroleum, where mixtures are separated into different components by difference of their boiling point as you apply heat on them. Now, the next we are going to look at now is types of cracking. Types of cracking. Number one is thermal cracking. Okay, thermal cracking. Here, the hydrocarbons of long chains are broken down by application of heat at a temperature 600 degrees Celsius. Okay, the hydrocarbon of a very long chain is broken down by application of heat at the temperature 600 degrees Celsius. Okay, the number 2 here is catalytic cracking. Okay, here the temperature here is reduced to 500. Okay, and reason is because we have catalyst added to it. Okay, catalyst is added to break down the long chain hydrocarbon into a mixture of smaller chain hydrocarbon. Then the catalyst we always use here is zeolite. Zeolite is the catalyst that is employed in this process. Okay, you can call the zeolite, you can say aluminosilicate. You can say aluminosilicate, right? This is used as a catalyst in catalytic cracking, all right? Then take note, in the thermal cracking here, thermal cracking and catalytic cracking will give you mixture of alkane and akene, okay, to obtain higher quantity or to obtain alkene, which is used in the plastic industry as a raw material. All right, then the last one we have here is hydrocracking. Hydrocracking. In this type of cracking, we don't need to obtain alkene again. Alkene is not obtained because as these components are produced, as it is being broken down, there is addition of hydrogen. All right, there is addition of hydrogen, and you know that alkene is very reactive. Alkene is very reactive more than the alkane. So the alkene will lose the pi bond. It will lose the pi bond to undergo addition reaction. All right, to undergo the addition reaction. Okay, so as it lose the weak pi bond, for instance, here is the pi bond. It will lose the pi bond to bind with the hydrogen, which is being added in this process of cracking. All right, that means the only product here obtained is a mixture of alkane, is a mixture of alkane. That is, no alkene is produced. No alkene is produced. The only mixture we obtain contains only alkane, and this is the product obtained in this type of cracking, which is hydrocracking. Okay, the next on the board we are going to look at now is reforming. Okay, let's look at reforming. Reforming. Reforming here on the board is the process of converting a long chain hydrocarbon into branch chain hydrocarbon, and the essence is to improve the quality. The very long chain hydrocarbon is converted into branched chain hydrocarbon, and this is achieved by application of catalyst. Right? Meanwhile, heat is not required. It is achieved by application of catalyst, and the catalysts here are, it can be platinum, it can be palladium. These are the catalysts used in reforming. Okay, now difference between reforming and cracking. Here is cracking, Then here is reforming. Okay, cracking here is to increase the quantity of hydrocarbon. The reforming here is to increase the quality of hydrocarbon. That's number one. Number two difference is that cracking here requires heat and catalyst. Reforming here only requires catalyst. No heat is required here in reforming. The number three occurs at a temperature higher than that of reforming. Then, while reforming here occurs at a temperature lower than that of cracking. These are the three important differences between cracking and reforming on the board. All right. The next we're going to look at now is the octane number, and that is going to be the last for today's video. All right. What is the octane number? Octane number on the board is the value that indicates the grade of petrol. Right? Is the value that indicates the grade of petrol. Right? That is to say, it shows how smoothly petrol burns. It indicates how smoothly petrol burns. All right. This octane value here, or the octane number, is obtained on a scale in which this is obtained on a scale in which 2, 2, 4 trimethyl pentane is the highest value, and heptane is the lowest value. All right, that indicates that 2,2,4 trimethyl pentane here indicate the highest value, and heptane here indicates the lowest value. All right, so as we have more of 2,2,4 trimethyl pentane, the petrol will be of high value or high grade of petrol. Right? Then if the petrol has more of heptane, it's going to be of very low value, or that will decrease the grade of petrol. Now, I would like you to understand that petrol with more of 2,2,4 trimethyl pentane, which is the high grade petrol, will burn smoothly in the motor engine. All right? This here will burn smoothly in the motor engine. All right, while the petrol with high heptane, that means is of low grade, will cause knock in the motor engine or can cause damage. It can damage the engine, or you say it will not burn smoothly in the motor engine. Now, according to your exam, for instance, JAMB, for example, there's a question they ask about a petrol that have 55 gram of 224 trimethyl pentane and that have 45 gram of heptane. And the question they ask here is for you to determine the octane number. All right. If you have a question like this, a petrol contains 55 gram of 224 trimethylpentane, then it also contains 45 gram of heptane. What is its octane number? The octane number here is 55 gram or 55. Reason, it is the 224 trimethylpentane that indicates the octane number. All right. So if the octane number here is 55, then we have another petrol that have 90 gram of 224 trimethylpentane. That means the petrol with 90 gram of 224 trimethylpentane will burn more smoothly than this because it has the highest octane number. All right, this is all we have for now. Thank you and God bless you. Please don't hesitate to like, to drop a comment, and to share our video to your friend. I hope this helps you a lot in your exam. Good day.